All right, does everybody have their paper out for notes today? Yes? All right, please look at the sideboard. What are we doing today? Factoring polynomials. And what I want you to notice, it says, today I will factor polynomials. What I want you to know is that tomorrow it's going to say, today I will factor polynomials. And Wednesday it's going to say, today I will factor polynomials. And Thursday it's going to say, today I will factor polynomials. And guess what's going to say Friday? Quiz. Yeah. Okay. But it's a quiz over what? Factoring polynomials. Okay? We're spending a whole week on factoring polynomials. That automatically means it's hard, right? No. It means that's important. Okay? The fact that we're spending an entire week on factoring should tell you that it means it's important. Okay? We're taking it little by little so that you can make sure to grasp everything. Because here's what you don't know yet. What you don't know is that we use factoring beyond just this week. Okay? It's one of those things that we're going to use when we start talking about quadratic functions. We're going to use it when we get to rational functions. And if we already know how to factor, it's going to make those two things a whole bunch easier when we get there. A whole bunch easier. Okay? So let's go ahead and get factoring down now so that we don't have to worry about it later. Fair enough? All right. So let's start off by talking about this. How about if I turn the screen on for you? Will that work? Okay. Probably. Okay. Have you ever seen that before? GCF? Greatest common factor. Okay, GCF means greatest common factor. And I need you used to looking for the GCF every single problem that we do. Sometimes it's going to make a difference. Sometimes it's not going to make a difference. But I want you to see it every single time. I want you to think of it every single time we do one of these problems. Okay? Well, what do I mean by that? I mean, what if we have a binomial? Wait, what's a binomial? Well, what's a polynomial? We already talked about that. You remember? Poly means many. What's nomial? Numbers or terms. Okay? So if polynomial means many numbers or terms, what's a binomial mean? Two. Two numbers or terms, right? So if I have a binomial that's just 2x minus 4, look at each term separately. And then think to yourself, do they have a greatest common factor? Is there something that both of these are divisible by? A 2, right? So if I factor out a 2, I'm going to end up with something that looks like that, right? Now, a lot of people think that multiplication and division are opposites of each other. And while most of the time that's true, here I went from this to something that's divided into its two parts. But I didn't really call it dividing. What did I call it? Factoring. Okay? So I could multiply this out to check to see if I got it right. What if I multiplied this out? I'd get 2x minus 4. Is that what I started with? Then I know this is correct. Okay? So multiplying and factoring can be opposites as well because we factor by dividing. Didn't I divide each of these terms right here by a 2? Yeah? Okay. So what happens if you have something like this? I'll give you a harder one. How about that? Is that good? 3x squared plus 5x. 3x squared plus 5x. Does that have a greatest common factor? Is there something that each term is divisible by? Not a number, but a variable. Don't they both have an x? What happens if I divide an x out of this term? What's left? 3x. Good. What's left when I divide this term by x? Plus 5. Done. So there won't always be a number I can divide out, but there might be a variable, which in this case isn't still a number, right? Just doesn't look like a number. It looks like an X, a letter. You okay with that? So first 3 problems on your homework tonight deal with finding the greatest common factor. Are you comfortable with that, or do I need to do one more example? Good? Okay, let's go on then. Let's see. What if we do this? Except I want that to be a 9. Sorry. X squared minus 9. How many terms are there? 2. So it's called a binomial, right? What's special about this binomial? Do you see anything that might be considered special? It's a 9. Yes, ma'am. What do you know about 9? Is that number special in any way? Can you take the square root of it and get a whole number or an integer? Yes, right? Can you take the square root of x squared? What times itself is x squared? X, right? So what does this sign mean? Subtract, right? I know that seemed like a really easy question. It wasn't a trick question. I'm just making sure you understand that this is a subtraction. This is a very special kind of problem. It's called the difference of squares. Why difference? Because it's subtract. Why squares? Because each of these numbers are squared numbers. I can take the square root of each one of these numbers and get a whole number, right? When it's the difference of squares, here's how you factor it, okay? When I factor the difference of squares, I get 2 binomials. When I factor the difference of squares, I get 2 binomials. One of my binomials, well, let's see. The first term in this binomial, what's the square root of x squared? What times itself is x squared? X. That goes here and here. What do you think goes in the other blank? How do you know it's 3? Square root of 9. 3 is here and 3 is here. What's left? The signs are left, right? We got to figure out what signs go where. Well, I'll just make it real easy for you. Let's make them opposite signs. Let's make one a plus and one a minus. Here's the fun part about these problems. You should never get them wrong because you can always check. Because if I multiplied it back out, I would use the distributive property, right? X times x is x squared. All right, that's good. X times 3 is 3x. Negative 3 times x is negative 3x. And what do you get when you have a 3x and a negative 3x? 0. And then negative 3 times positive 3? Done. Does that make sense? Any questions about it? Now, some of you are looking at me like right now like it seriously can't be that easy. Yes, it can. You want me to make you a harder one? Will that make you feel better if I give you a harder one? All right, here's a harder one. 64 x squared minus 81. Is it the difference of squares? First of all, is it a difference? Yes. Is that a squared term? Then what's the square root of it? 8x. Is that a squared term? Yes. Then what's the square root of it? 9. So give yourself 2 binomials to fill in. What goes in the first part of each binomial? 8x here, 8x here. What goes in the second part of each binomial? 9 here, 9 here. What kind of signs do I have? Okay, I'm going to try to trick you. Look what I did. First problem I did minus and a plus. And then this problem I did a plus and a minus. Which one's right? Why are they both right? It's the same thing, right? Does it matter what order we multiply in? No, what has to be true about the signs, though? They have to be opposite. Now, you're still looking at me like, You told us you were going to give us a hard one, and then you gave us that one instead. Guys, that's as hard as I can make them. The only way I can make them harder is to make the numbers bigger. Like 144, which you know is 12, right? Squared is 12. Stuff like that. That's all I can do to make these harder. Okay? I am going to give you one more, and I'm going to try to trick you. Are you ready to not be tricked? Okay. Don't let yourself be tricked. (2x squared minus 50). Alright, so that's the difference of squares. Is it the difference? Yes, it's the difference. Is that a squared term? Yes? Then what times itself gives me 2x squared? Uh-oh. Is 50 a squared term? What times itself equals 50? It's not the difference of squares, is it? But each of the numbers are divisible by 2. Excellent. So, should I factor a 2 out of each term before I start? Yeah? If I divide that term by 2, what am I left with? X squared. If I divide that term by 2, what am I left with? Minus 25. Is that the difference of squares? Well, is it the difference? Yes. Is that a squared term? Then what's the square root of it? X. Good. Is that a squared term? Then what's the square root of it? 5. So I just drag the 2 along, like one of those friends that you have to take around with you, even though you don't want to hang around with them. No names, no names. And I give myself 2 binomials. What goes in the first part of each binomial? Good. What goes in the last part of each binomial? 5. And what about the signs? They're just opposite. Done. Now, I told you I was going to only give you one more example a minute ago to try to trick you. Now I'm going to give you another one. Because, you know, you never believe teachers when they say, okay, one more example, right? All right? Okay. Are you ready to be not tricked? Okay. Let's see. How about... What about that one? Is that the difference of squares? Wait, what? It's not a difference. So it's the sum of squares, right? All right. Watch very, very carefully. If you recognize that it's the sum of squares, watch very carefully. Done. Now, this one happens to have a greatest common factor. So if I took a greatest common factor out, I would get that, right? Now if I go to factor the sum of my 2 squares, watch carefully. Okay, done. What did I do? Nothing. You cannot factor the sum of 2 squares. So all I can do in this case is take out the greatest common factor. If this right here, x squared plus 9, was my original problem, if that was my original problem, you know what I would write? What is it called when you can't factor something? When you can't break a number down into its prime factors, what is it called? It's prime, right? You cannot factor it, so it's prime. So this problem is a little bit tricky. I did it that way on purpose, right? Because I told you I was going to try to trick you. All you can do is take out a common factor, a greatest common factor, because this is the sum of squares and it cannot be factored any further. It is a prime binomial. Questions? All right. Ready for the next examples? They're all grouped together as well. Okay? And they look like this. Tell me what you Tell me what you first think about when you see this. It's a difference, right? That's a good start. It's a difference. Is it the difference of squares? No. What is it the difference of? Is it the difference of cubes? Yeah, it is. What times what equals x to the third? X. What times what equals 8? 2. So here's how you factor the difference of cubes. You get a binomial and a trinomial. Dun dun dun. What's trinomial mean? 3 terms. Okay? All right, you ready to fill in our binomial? Let's fill in the binomial first. And I think you already know what goes in there because you already answered my questions, right? What's the cube root of x cubed? What times itself equals x cubed? X. That goes right there. What times itself equals 8? 2. That goes right there. Okay? So for argument's sake, for just a second, we're going to call this an A term and we're going to call this a B term. All right? Because we're going to fill out the trinomial by using the binomial. We're not even going to pay attention to the problem anymore for now. Okay? The first term in the trinomial is a squared. So whatever is right here, square it. What goes right here? X squared. The second term in the trinomial is a times b. What is a times b? 2x. And the third term in the trinomial, any guesses? Yep, b squared. Excellent. So what is b squared? 4. So what's missing? The signs, right? All right. What's the sign in the problem? A minus. That's the sign in the binomial. The next sign is opposite of that. The last sign is always plus. Questions? You got it? Then let's do another one. Let's do this one. 125x cubed minus 64. What do you notice about both of those terms? First of all, it is a difference of... Is it the difference of cubes? It looks like it might be because there's an x cubed, right? What times itself equals 125? If you look on the board, the direction my pen is pointing, I gave ourselves a little cheat sheet over there. I squared all numbers from 1 to 10, and I cubed all the numbers from 1 to 10. So what times itself is 125? It's 5. Okay? What times itself equals 64? 4. All right? So let's set up our binomial. So now we've decided it is the difference of cubes. So let's set up our binomial and our trinomial. Okay? Well, it goes in the first term of the binomial. Close. What's the cube root of 125? 5. So 5x goes right there. And what's the cube root of 64? 4. Now, how do we get the first term in the trinomial? Square the first term in the binomial. What is 5x squared? What's 5 times 5? What's x times x? So 25x squared. How do I get the middle term of the trinomial? Yeah, multiply these two terms together. 20x. And how do I get the last term in the trinomial? It would be b squared, which is, in this case, is 16. What's left to do? The signs. What's the sign in the problem? Then that goes in the binomial. Plus, plus. This one's opposite of the first one, and the last one's always plus, right? Any questions about that? So can I try to trick you again? Is that okay? I know you guys like it when I trick you. Not really. How about if I write the problem correctly? Would that help? Okay. Is that the difference of cubes? What is it? Is it the sum of cubes? You said it's a sum. I agree with that. Is it the sum of cubes? What times itself equals 27? 3. What times itself equals 1? 1. So is it the sum of cubes? Here's the best part. You already know how to do it. It's not prime. We can factor this, but watch. Guess what you get? A binomial and a trinomial. Guess what goes in the binomial? What goes here? 3x. And what goes here? 1. What goes in the first term of the trinomial? Yeah, square that. 9x squared. What goes in the middle term of the trinomial? 3x, because it's 3x times 1, which is just 3x. What goes in the last term of the trinomial? 1 squared, which is 1. Oh, no. Yeah, I'm just going to ignore that part, okay? So what sign goes right here? What's the sign of the problem? Exactly. What's the next sign? Opposite of that. And what's the last sign? Plus. It's always plus, that last sign. Questions? All right, you want me to give you one really, really hard one? Just see if you can do it? Yes? Okay, good. I like that attitude. Let's make it plus just for fun. Okay, now Courtney's figured out something. I just saw it in her face. She knows that 375 is not a cube number because it's not on that list on the sideboard. There's a 3 number, but it's not 375, it's 343, right? So she just thought to herself, maybe there's a greatest common factor I have to get rid of first. So she was like, maybe it's 2. Is it 2? Are they both divisible by 2? No. Why not? Because that one's not, right? It ends with a 5. It's not an even number. Okay, maybe they're both divisible by 3. Are they both divisible by 3? Okay, you guys don't know the trick then, do you? Okay, watch. Here's the trick. What's 6 plus 4? 10 plus 8? 18. Is 18 divisible by 3? Yes? Then so is this number. For real. For real. What's 3 plus 7? 10 plus 5? Is 15 divisible by 3? Then so is this number. It works for 3 and it works for 9. But we know it's not 9 because is 15 divisible by 9? No, 18 is, but 15's not. So let's factor out a 3. What do we have left? 216 x to the 6th plus 125 z to the 3rd. Is that the sum of cubes? Is 216 on our list of cubes? Is 125 on our list of cubes? Okay, so all that's left to figure out is this. Is that a cubed number? What times itself is x to the 6th? What times itself is x to the 6th? Isn't x squared times x squared times x squared x to the 6th? Remember, when we're multiplying like bases, what do we do with the exponents? We add. Yeah, absolutely. So is this the sum of squares? Yeah? So let's set up our binomial and our trinomial. What goes to the first term right here? Wait, what are we doing with the 3? We just drag it along, right? Okay, so what goes in the first term in the binomial? What's the cube root of 216? What times itself is 216? 6. So 6 x squared, absolutely. What goes here? Second term in the binomial? 5z. Good job. First term of the trinomial is this term squared. 36 x to the 4th. Very, very good. What goes in the middle term of the trinomial? This times this. 30 x squared z. Good. Last term of the trinomial? Yeah, very good. 25z squared. Signs. What goes here? Plus, minus, plus. Questions? So today, the first thing I want you to think of is what? What's the first thing I want you to think of? Greatest common factor. Is there a greatest common factor I can factor out? Then I have to decide. All the problems we're doing today, or most of the problems we're doing today, have two terms. Is it the sum of squares? Is it the difference of squares? Is it the sum of cubes? Is it the difference of cubes? Once you figure out which one of those is the answer, you know how to factor it now. Any questions? Okay, you have the rest of the period to work on your homework. Mark as I go. Peace.